Hi, this video is a second video on the first derivative test. We're assuming you have some basic understanding of the first derivative test by this point. So this is just a quick reminder of the process that's involved and how you can determine where the function is decreasing and increasing and where you have relative minimum or maximum based on what's going on with its derivative. Okay, so I'm not really spending any time on that. I'm going to move straight to problems. Alright, so our first problem is find intervals where this function is increasing and decreasing. F of x equals 2 over x. So we're going to start by finding f prime of x, which is going to be negative 2 over x squared. We're going to set it equal to 0. This is never going to equal 0, but do we have any critical points? We do have a critical point here at x equals 0. Why? Because the derivative does not exist there, so it is also a critical point, and we have to acknowledge that. And sometimes when students miss that important information, they often can get wrong answers because those are also critical points and have to be addressed. Alright, so this is going to be our f prime of x, this is going to be our f of x. So if you check the signs here, it's going to be minus and a minus, so it's decreasing. Please remember this is discontinuity here, so you can't really use that point for anything. So what do we know? The function is going to be decreasing wherever it's defined. So it's going to be on an interval from negative infinity to 0, and also on an interval from 0 to infinity. It's not increasing anywhere because there are no intervals where the first derivative is going to be positive. The function is decreasing and decreasing. Okay, f of x equals 1 over x squared. Do the same kind of work. So we start by finding the derivative, which is going to be negative 2 over x cubed. Set it equal to 0. Again, this expression will never equal 0, but it does have a critical point at 0 as well. Because the first derivative does not exist at that point. It is a critical value. Okay, so now we can do a number line. Put our critical value here. It's actually going to be an open circle. Put f prime of x here. Put f of x here. So what's going on here? This one's going to be positive on this side and negative on this side, which means it's increasing, decreasing. Okay? So the function is going to be increasing wherever the first derivative is positive, which is going to be on an interval from negative infinity to 0, and the function is going to be decreasing wherever the first derivative is negative, and that's going to be on an interval from 0 to infinity. I also want to point out one thing about this problem. This is not a relative maximum because the function is not defined at this point. The function actually has a discontinuity. It's an asymptote at this point. So just because the sign changes here is not enough for you to make an assumption that this is a relative extreme. Okay, moving to the next problem. So we need to find all relative extreme of this function and state where it's increasing, decreasing. So you're going to have to use the quotient rule here to find the derivative. So the first derivative is going to be 2x times x squared plus 1 minus x squared minus 1 times 2x all over x squared plus 1 squared. So when you simplify all that, you're actually going to get 4x over x squared plus 1. I don't want to spend too much time on algebra. Here you can check that, distribute, and you will see that 2x cubed is going to cancel. So we set it equal to 0. The denominator will never be 0, so we don't have to worry about any excluded values here, but the numerator can equal 0, and that's going to happen when x equals 0, so that's going to be our critical value. So we're going to make our number line, put 0 on it. By the way, I want to remind you this function is defined everywhere. And the signs of the first derivative will be negative here and positive here. This is f prime of x, this is f of x. So the function is decreasing and increasing. So what do we have here? We have a behavior where the function is decreasing, where the first derivative is negative, and that's going to happen on an interval from negative infinity to 0. The function is increasing on an interval from 0 to infinity. That's where the first derivative is positive. And we are going to have, since the function is defined at 0, we're going to have a relative minimum here, because we have this critical value and our first derivative changes from negative to positive. So it's going to happen at x equals 0. Okay. Next problem. Find the relative extreme of f of x equals x times e to the power x and state where it's increasing, decreasing. Alright, so now we're getting into some transcendental functions. So f prime of x, we're going to have to use the product rule here, which is going to be e to the x plus x e to the x. We can factor out e to the x, which is going to leave us with 1 plus x. And we're going to set it equal to 0. This function is defined everywhere. It's a continuous function, so we don't have any critical values where it does not exist, but we do have critical value at negative 1, because at negative 1 this expression is going to equal 0. E to the x never equals 0. So that is our critical value, and we are going to plot that on our number line, negative 1. So what's going to happen? E to the x stays positive all the time. We're just going by 1 plus x. The sign of the first derivative will be negative here and positive here. So our function is decreasing on this side and increasing on this side, right? That's what we're going to state. Decreasing, remember the function is decreasing wherever its first derivative negative, so that happens on an interval from negative infinity to negative 1. The function is increasing wherever its first derivative is positive, and here it happens on an interval from negative 1 to infinity. Our function is defined at negative 1. It is a critical value here. The sign of the first derivative changes from minus to a plus. This is a relative minimum. And we're done with this problem. Okay. Alright, something a little bit more complicated, but not too bad. So this function, you need to find all the same kind of answers, relative extrema, and where it's increasing and decreasing. So we're going to start by finding f prime. As always, we're going to use the product rule. So the derivative here is going to be 2 times x minus 1 times e to the x plus x minus 1 squared times e to the x. So what can I do? I can factor out 2. No, I cannot factor out 2. I can factor out e to the x times x minus 1, and that's going to leave me with 2 plus x minus 1. So my derivative finally is going to be e to the x times x minus 1 times x plus 1, and we set it equal to 0. That's going to give me two values, x equals 1 and x equals negative 1, which are going to be our critical points. Okay, so make a number line. I have two critical values, negative 1 and 1. By the way, this function is defined everywhere, so we have no problems with continuity here. F prime of x, f of x. And we can go ahead and figure out the signs. There will be plus, minus, plus. So the function is increasing, then decreasing, then increasing. So, what can we conclude here? The function is increasing wherever the first derivative is positive, and that's going to happen on the interval from negative infinity to negative 1, and also on an interval from 1 to infinity. The function is decreasing wherever its first derivative is negative, and that's going to happen on an interval from negative 1 to 1. What about the relative extrema? At negative 1, the first derivative changes from positive to negative. That's a relative maximum. And at 1, the first derivative changes from negative to positive. That's a relative minimum. Okay, and we're done with this problem. Okay, we have a couple more. So find all the relative extreme of this function, same kind of answer. I'm sorry, question. So f prime of x is going to be, we use quotient rule here, it's going to be 2x times x squared minus 4 minus x squared times 2x divided by x squared minus 4 squared. So when you go through everything and simplify it completely, you're going to get negative 8x divided by x squared minus 4 squared. Okay, so where you need to be careful. This is going to equal 0 when x equals 0, right? Because the numerator will be 0. But this, the function itself and this, the derivative of the function, have discontinuities at two values, x equals 2 and x equals negative 2. Because this is where the derivative will be 0. The function itself actually has discontinuity at these points as well. I'm going to have negative 2, I meant. And it's going to have vertical asymptotes. So we need to figure out how the function is going to behave based on its derivative, right? So we have three values we have to put on the number line. So we have 0, we have positive 2, and we have negative 2. And now we're going to determine the signs. The signs will be, and please remember, this is a discontinuity and this is a discontinuity. So it's going to be plus, plus, minus, minus. So this is f prime of x, this is f of x. So what do? We are going to write our conclusions now. So the function is increasing wherever the first derivative is positive, but remember there is a discontinuity here, which is going to go from negative infinity to negative 2, and it's also going to go from negative 2 to 0. The function is decreasing where the first derivative is negative, which is going to be from the interval, on the interval from 0 to 2. Remember, 2 is a discontinuity, and also from 2 to infinity. What are relative minimum, relative maximum? Well, you have to be very careful. These 2 points are discontinuities anyway, so they would not be, and besides, you don't have any sign changes there. But you do have a sign change at 0, and this function is defined at 0. And the first derivative changes its sign from plus to minus, which means it's a relative maximum. So we have a relative max at x equals 0. Okay. And we got one last example. So I can get to it. There we go. F of x equals ln x over x. Find relative extrema and where it's increasing and decreasing. Right, so we're going to do f prime. We need to use the quotient rule, which is going to be 1 over x times x minus ln x divided by x squared, which is going to be 1 minus ln x divided by x squared equals 0. So what are the discontinuities here? Well, this one you have to be careful with. Remember, ln x, for ln x, x has to be greater than 0. So we actually don't need to worry about any values that are not greater than 0. So anything negative and 0 will be excluded. But we also know that 1 minus ln x will be 0 when x equals e. And that's going to be our critical value. So when we make a number line here, we're going to start at 0 and we don't need to go to the left of it at all. And then we have e. So this is f prime of x, this is f of x. Our first derivative will be positive here and will be negative here. So the function will be increasing then decreasing. And then we write that the function is increasing on an interval from 0 to e, because the first derivative is positive here. The function is decreasing on an interval from e to infinity. What do we have at e? The first derivative changes from positive to negative. We're going to have relative max. Okay, and that concludes this video. I hope this was helpful.